Today's topic is about column chromatography, revision of column chromatography. Okay, generally chromatography nothing but based on the color we are going to determine the number of components present in the given mixture, as well as we are going to identify the separated components also. Okay, means chromatography, with the help of chromatography we can identify the number of components, as well as we can separate the number of components, as well as we can determine the type of the component also, whether it is belongs to alcohol or any other amine or any other chemical character. Okay, first come to the column chromatography. Okay, every chromatographic technique involves in the usage of two different phases. One is the SP, means solid phase, and second one is the mobile phase. Okay, in solid phase, in column chromatography, stationary phase is solid and mobile phase is liquid. For example, here solids we are using alumina or silica gel, and mobile phases we can use carbon tetracl4, benzene or ethyl alcohol, any other solvent. Okay, these are the solvents we can use in column chromatography, and every chromatography includes 4 steps. That is, the first step is preparation of stationary phase, second one is introduction of the sample, and third one is introduction of the mobile phase, and fourth one is the identification of the compounds, and fifth one is about RF values. These are the common points in all chromatography techniques. Again, I am repeating, chromatography means which is useful for the separation of the number of components identification and separation of the number of components present in the given mixture. After separation of the components, we are going to identify the nature of the and chemical component of the compound with the help of RF value. Okay, and every chromatography involves in the usage of two different phases, which is called as solid phase and mobile phase. Okay, in column chromatography we are using stationary phase is solid and mobile phase is a liquid. For solids we can use alumina or silica gel, and mobile phase liquids like solvents CCl4, benzene and ethyl alcohol, etc. Generally, stationary phase means in a chromatography experiment, the phase which is a stable one is called as a stationary phase, and mobile phase means in a chromatography experiment, the phase which runs through the stationary phase is called as a mobile phase. Generally, mobile phase here in column chromatography used as a liquids. Now, in all chromatography techniques involves around 4 to 5 steps. That is, the step 1 is about preparation of, first we are going to prepare stationary phase, second one is introducing the sample, and third one is introducing the mobile phase, and fourth one is identification of the components, and fifth one is about RF values. Okay, now come to the first one, that is the column, empty column I took here in first small Roman number 1. See the image. This one I took empty column nothing but which is having the similar structure like burette, but the width of the pipe is very high. That is called column, which is going to use as a stationary phase by doing some modification here. So see here, first step, preparation of stationary phase. First we have to take the empty column, then here we are using stationary phase is a solid now. Take alumina or silica gel. Okay, first take alumina and add a suitable solvent like here. Alumina is a powder. Okay, now we are going to paste this alumina paste in the empty column. It means this area we are going to paste with the alumina paste. So first we have to take the alumina. It is a solid powder which is mixed with the ether or acetone. Okay, to convert this alumina as a paste. After converting this paste, it is placed throughout the empty column. After placing this empty column, you will get this structure like this Roman number 2. Means the column is coated with the, see here, this area already I coated, these all whitish area. It is coated by the alumina paste. After pasting, within fraction of seconds, the added ether or acetone, it will be evaporated within the fraction of seconds. Now in the Roman number 2, okay, the empty column is coated with the alumina paste. Now it is used as a stationary phase. Okay, again I am recalling the first step. First, take the empty column, that is small Roman number 1, and now in column chromatography stationary phase is solid. We are using here silica gel or alumina, any one you can take. Now I am explaining with the alumina. Take the alumina into a beaker and add a small quantity of the ether or acetone. Okay, this alumina is, by adding ether, it is converted as a paste. Now this paste is pasted in a empty column, means this area is totally pasted with the alumina paste, okay, which is shown in the Roman number 2. Now within fraction of seconds the added ether is evaporized. Now the alumina is pasted in the empty column, which is worked as a stationary phase. Now second one is introduction of the sample. So see here this area, okay, upside, okay, some more whitish color is there. So whatever the sample you are going to separate, take that sample in a watch glass and again have to add a small quantity of the ether or ether or acetone. Why? Because if the given sample is a solid, so it can't stay here. So for that we are adding a small quantity of ether and the given sample is converted in the form of a paste. That paste is pasted the upside of the column. Okay, see here this one sample. Okay, that location is called sample spot. Okay, that is completes about the introduction of the sample. Again I am repeating introduction of sample. Okay, take the given sample mixture and add a small quantity of ether to convert the given sample mixture in the form of a paste. That paste is pasted upside of the column as shown in the figure Roman number 2. Okay, that is about the introduction of sample. After that we are introducing the mobile phase. That is introduction of mobile phase. Okay, this mobile phase means so many mobile phases we can use in column chromatography liquids we can use. So based on the nature of the given given sample, we have to select the suitable solvent like a CCl4, benzene or ethyl alcohol, so many. For example, if you take CCl4, the given sample mixture is won't separated. Then again begin the experiment from starting. Then we have to go for the more stronger one like a benzene or any other. Okay, like this way we are going to select the suitable solvent. After selecting the suitable solvent, we have to introduce from the upside. See here in the diagram 3. Okay, so same as it is this diagram shown here. Again we are introducing mobile phase from upper side of the column. Okay, if you pour the mobile phase from here, ultimately it will move the downwards. While it is moving downwards, whatever the components present in the sample mixture, okay, whatever the components present in the sample mixture, okay, it is a sample mixture. These components are going to dissolve in the mobile phase. Okay, mobile phase is having high polar character, hence it will move very faster. Okay, now like in this way mobile phase is moving. Okay, already this number of components are dissolved in the mobile phase. Okay, so the dissolved number of components also moving downwards with the mobile phase as shown in the figure number 4. See here I shown one A and one B, means the number of different components present in the sample mixture are going to dissolve in the mobile phase and it is also moving downwards in the column with the mobile phase. So mobile phase will move first. Then based on the polarizing character of the number of components with the surface of the column, someone can move fast, someone can move slower. So based on that we got here two different layers. One is the layer A and layer B. Why we got here two layers means which indicates that based on the number of layers, which indicates that the given sample mixture has those number of components. So here we got only two layers. So the given sample mixture has two different components. Okay, which is adsorbed weakly on the surface of the column, which can move fast. That is nothing but here this one A. A is adsorbed very lightly with the surface of the column, so it is moving very faster. Okay, so by pouring more quantity of mobile phase, we can by opening the nozzle of the column, ultimately we can separate a component into the this Dewar flask. Means by pouring more mobile phase, okay, this A totally moves downwards and it is collected into the Dewar flask. In this Dewar flask, now we are having two different components. One is mobile phase. Okay, mobile phase is a liquid one which can move very faster. So in this Dewar flask, we are having, see here, this diagram and this diagram. Okay, by pouring more number of more quantity of mobile phase in this Dewar flask, we will get a mobile phase with a layer. Okay, and after this, take one more separate Dewar flask and keep here. Again, pour more quantity of mobile phase, then which can take the mobile phase with the B layer into the another Dewar flask. Now, first we identified with the help of this diagram, we identified how many number of components present in the given sample mixture, and with the help of this Dewar flask, means with this diagram, we are separated the number of components also. Okay, this is about the identification of components. Okay, now after that, the separated components are identified with the help of RF values. Okay, RF value nothing but, see here, RF value nothing but, see here, RF value nothing but, the definition of RF value equals to the A traveled distance by solvent front. Means if you take any composite, RF of A, RF means retardation factor. Okay, these RF values are able to determine the separated components. Means whether it is belongs to which type of a chemical composition. Okay, so RF of A equals to A traveled distance by solvent front. If you take RF of B, B traveled distance by solvent front. Here RF of A, RF of B. Okay, now how we have to determine the RF value? Means with the help of a scale, we have to measure the traveled distance from fourth diagram. See here, I marked here from solvent front distance from here to here. Okay, from here to here, I assume the solvent front travel distance is 10. Okay, solvent front travel distance is 10, and similarly I assumed from here, from this area here to here. Okay, okay, that is the distance traveled by A, I assumed as 6. The distance traveled by A, I assumed as 6. And similarly, the distance traveled by B, here, the distance traveled by B is assumed as 3, the distance traveled by A is assumed as 6, and the distance traveled from top to bottom is assumed as 10. Means with the help of a scale, we are going to measure the total distances or traveling distance of solvent front and separated components. So according to the definition, RF values, RF of A equals to A travel distance by solvent front. A is here, distance is how much? A travel distance is 6 and solvent front is 10. So 6 by 10 equals to 0.6. This is the RF of A. Similarly, if we calculate for B, you will get B travel distance is 3 divided by solvent front is 10. So it is 3 by 10, you will get a 0.3. So roughly we are assuming one reference table. Okay, just roughly we are assuming, it is not exact one. Reference table is showing that if it is the RF is 0.3, it is alcohol, 0.6 is acids, and 0.9 is amine. Just we are taking one example, assuming. Okay, now see here, RF of A is equals to how much? 0.6. But according to our reference table, 0.6 nothing but which is belongs to acid. So the separated A component is belongs to acid. Similarly, RF of B equals to how much we got here? 0.3. So here according to the reference table, 0.3 means alcohol. So the separated component is belongs to the alcohol. Like this way, with the help of RF values, we are going to determine the composition of the separated components. Okay, this is about the column chromatography, and all chromatography techniques are having the same process, but the diagrammatical and equipments are different, but having involves in the same type of steps. That is, Preparation of stationary phase, introducing the sample, introducing mobile phase, and identification of number of components, and final one is the RF values. Okay, thank you.